So in this video, we're going to talk about networking fundamentals part 2, and we're going to talk about protocols. And all protocols are just these rules that, how do we connect, right? There has to be a set of rules that say, how do I talk to you? For example, if you're talking to a friend, you and your friend use a very specific way of talking or a very specific code. Like you have this internal dialogue, this internal language that you use to communicate with one another. But if you try to use that same language to talk to your parents, a lot of it is probably going to get lost in translation. So the way you talk to one person is different from the way you talk to another person. That is to say that when two devices on the internet connect with one another, there has to be a standardized set of rules, and these standardized set of rules are known as protocols. So why don't we go over some of these protocols now? We'll talk about file transfer protocol, we'll talk about mail protocols, and there's a whole lot more, but I think these are the most common ones that you need to know right now, and we can talk about the rest later. Like I said earlier, there's many different protocols that we use, and these different protocols has very specific functions. So the file transfer protocol, and all the file transfer protocol is a set of rules that allow you as the client to upload files to the server. And every time you look at a website, or every time you look at a Google Drive document, we're transferring a file from one end to another. And people that build websites and people that build apps commonly use file transfer protocol to transfer web page files from their computers to the web server. So in file transfer protocol, it's easy. We're just saying, like, if I've written a bunch of files on my computer and I have them, right? So I want to be able to take all of the things that I've written as a document and then transfer them to the server. So all you're saying is, if I'm a client and you're the server, I'm basically just taking the files that I've written, right? And I'm handing them to you. Here, you're the server. Go ahead and take these files, okay? And then as a server, you can now broadcast them worldwide and say, look, these are the files that I've gotten from the client. That's all it is. That's all it really is. I have these files. I give them to you, and then you do your best to broadcast these files online. And whenever you're doing like file transfer protocols, whenever you're building websites, whenever you're coding, in essence, you're basically doing one form of CRUD or the other, right? You're creating a file, you're reading a file, you're updating a file, you're deleting a file. And that's all you're doing, okay? So remember, in FTP, I'm saying that I, as the client, are giving files to you, the server. So let's talk about mail protocols. And mail is broken down into, realistically, 3 different protocols. And there's 2 servers involved for mail, and we have an incoming mail server and an outgoing mail server, okay? And the outgoing server uses a SMTP, so a simple mail transfer protocol. SMTP is the outgoing. But when we talk about an incoming mail server, there's 2 methods. We have POP, what's currently now POP3, so level 3, or we use IMAP. Now here's the big difference. Here's the big difference between POP3 and IMAP. In a POP3 mail format setting, the simple protocol is this. The post office protocol says this: give me the mail from the server and then delete whatever you have. So just give it to me. It's asynchronous. So that means as soon as I download the mail from you, the mail server, it's gone. It's like you walking to your mailbox, right? You walk to your mailbox, you pull the mail from your mailbox, and then if you lost the letter or your dog ate it or whatever, it's gone. It's permanently gone, okay? So the benefit of POP is that your server doesn't have to store all that mail. There's IMAP, okay? So the IMAP protocol works like this. It basically says, you, the server, give me a copy of my mail. Meaning, you make a copy of my entire mailbox and you show me the copy of my mailbox. All right? So you're the mail server, you give me a copy of it, and I CRUD the copy. I create, read, update, delete the copy. And then as soon as I do that, it syncs. All right? That means whatever I have and whatever you have are synced, or I just want to read it. For example, a lot of you use Gmail or other internet mail. You're basically reading the message, a copy of the message, and then that's it. If you want to delete it, you can permanently delete it from the server, but if you just want to leave it there as a read message, you can do that. And the great thing about IMAP is that, well, you can come back later and then look at these messages, meaning a year from now, you can go back and say, what was that email message that sent, right? So the downside to an IMAP server is that you start filling up space, because all you're really doing is looking at a copy of your mail. You're not downloading the mail off a server. You're just making a copy of it. And eventually, if you've got, limited storage in your inbox, in your mail account, that mailbox is going to fill up and you need to eventually clean it out. But I argue that services like Gmail, if you've got, gigabytes of storage, then there's a lot of mail that could be stored. You could store years and years and years and years of mail and not even touch the maximum storage capacity that like Gmail gives you. So here's HTTP, and all this is the Hypertext Transfer Protocol rule to say, how does a web server communicate with the web browser? So a web browser is a piece of software that runs on your computer, and it needs a way to communicate with the web server, and this is the way we do it. We use an HTTP request. I send the request, and then it comes back to me, and there's actually a long chain of events that happen along the way. It goes to the DNS server, and it goes to a bunch of different servers, but we'll get to that later. But what you should know is all the HTTP does is that it builds a request and it sends it to the server, and the web server facilitates the request and gives you back your information. So whenever you make a call to your Netflix server or whatever, then you're just basically using HTTP. And there's some underlying protocols like UDP, but we'll get to that later as well. Now let's talk about TCP/IP, the Transmission Control Protocol. This is by far one of the most important protocols, and without this, the internet as you know it will stop working. So the Transmission Control Protocol is basically the official communication protocol of the internet. Everything runs off of TCP/IP. So TCP/IP basically is a way to say, how do I communicate with the internet, and how do I make sure that the information you get isn't corrupted or broken? And that's kind of important that we understand that, right? It's easy to say, give me information. We have to make sure it's not corrupted. For example, if you've ever played the telephone game, right? Everyone stands in line and one person gets a sentence that they have to say down the line. And then at the end of it, the sentence comes out completely different. It is because the message has been corrupted along the way. Well, TCP/IP makes sure that your message is not corrupted, and it uses a checksum format. So, what is the purpose of TCP? It's to ensure the integrity of the network. And what TCP does is we break apart the file into individual packets, and these packets contain information such as destination, where am I going, what sequence am I in, and these values to verify the integrity of the data. So let's talk about checksum values. CHECKSUM. So checksum basically says I have information, right? I have this piece of information and I'm going to give it to you. But since this file is so big and the internet has to be broken down to pieces anyway, how do I make sure that you get a copy of this in perfect order? And so what I'm going to do is I'm going to rip this up into billions of pieces, and then I'm going to give you something called a header. And so I give you the little packet, this little piece, and then there's a header that goes on top or encapsulates it. And when you receive it, you open the header and say, this is what it's supposed to look like. This is piece number 1 of a million. And these are the instructions to put it back together. And then basically after you receive it, you send me back another piece of information that says, yes, I've received it, so thank you very much, send me the next one. That's basically how checksum works. You're saying, I have a map of what it's supposed to look like, and then I'm going to assemble it, and then I'm going to put it all together, and then I'm going to verify with you that I've done it. So, for example, let's say you download a lot of torrents, right? You download a lot of illegal shows, and don't say you don't. I'm pretty sure you do, right? Let's not do that. But anyway, that's kind of how it works, right? You have this movie that you want to download. It gets broken up into a billion pieces, and then you pull these pieces from different users, but you have a map of what it's your computer has a map of what it's supposed to look like put together, and so your computer just puts it all together, and that's how checksum works. It verifies the integrity of the file. So here's a simplified TCP packet diagram. We have a header that I know where I'm going, who it's coming from, and the checksum. And then finally we have this data, the piece of the data that's attached to the header. Now, finally with TCP, used together with IP, we can transmit files over the internet efficiently. IP takes over after TCP creates the packets. So after TCP says, I've ripped it up, I made all these packets, IP now says, here's where it's going to go, okay? So when the destination is reached, TCP verifies the integrity of each packet using the checksum. And if it's broken or I got a bad packet, then TCP says, hey, give it to me again. Give me that copy again because you gave me a terrible packet and it's broken. IP. And so working in harmony with TCP, all IP Internet Protocol is just a set of rules that's sent between these computers. And IP says, how do I get there? IP is like the post office, right? It knows how to send everything to the correct address. And then again, once sent, the packet gets successfully forwarded to the next closest router. So basically, in this IP packet system, it's not a straight shot, right? It's not a straight shot from me to you. There are probably hundreds of computers in between us, and I route this information all the way to you. If you get a chance, go online and look up trace routing, and then you can understand how that works. So here's a tool for visual trace routing, and you know what? Let's go ahead and trace howardcam.com, and then let's trace it, and then you can see all the pathways I need to get to my destination. So one is where I am. I'm not in Sweden, but you know, you get the point. So we go and we make all these hops, all of these hops. How many hops? So this is an IP address. It goes from this IP to this place, to this place, to this place, to this. It goes all the way down until we finally hit the server, right? And you can tell in milliseconds how long it takes to hop from every computer. So this packet hops from 1, 2, 3, and so we make all of these hops until we finally get to our destination. And if we look at this map, let me just blow this map up. Take a look at that, right? So, you know, we're hopping all over the, you know, halfway across the Atlantic, all the way across the Atlantic, right? So hops here, then, you know, then back here and back here again. It's great that all this information is hopping all over, and it takes milliseconds. It doesn't even, you're not even affected by it. So I hope that was a good example of visual trace routing, and that kind of concludes network this part 2. So yeah, if you have questions, again, just email me, comment, whatever. All right, and then I'll see you in the next lesson.